Hello, everybody, and welcome to the December issue of the Virtual Planetarium with Pete Lawrence and myself, Paul Abel, and we'll be starting, as ever, in the inner solar system and working our way outwards. And to start, then, the innermost planet, Mercury. It's an evening planet and rather poorly placed at the start of December. It's going to be a tricky object to see. Inferior conjunction, that's where Mercury is between us and the Sun, occurs on the 6th of December, and after that, Mercury reappears in the morning sky, where it gradually gets a bit better. Good chance to see it towards mid-month, but it's still a difficult target, I think.
It is. It does get reasonably good, actually, towards the end of December. On the 23rd, for example, it's at magnitude minus 0.2, and that's when it's at its greatest western elongation, rising nearly 2 hours before the Sun, which isn't too bad for Mercury. But it's always a tricky target, as you'll well know, because you observe Mercury quite a lot. But its outer solar system neighbour, Venus, which is much brighter, of course, is getting better and better as the days pass. Venus has been in the evening skies as we've been heading up to December, but it has been quite low, and that's made it quite difficult to see. But as we go through December, it starts getting higher in the sky. It will be approaching greatest eastern elongation, which occurs on the 10th of January next year. So if you're looking at Venus through a telescope, you'll see it as a gibbous disk at the moment. But by the end of the month, it actually brightens to magnitude minus 4.2 and sets 4¼ hours after the Sun. So that gives you a good opportunity to see it in darkening skies. And it'll be a welcome return, won't it, Paul?
It will. I have missed Venus in the evening skies. I should say, if you're a visual observer, it's best absolutely not to observe it in a really dark sky because you'll get glare from the disk, as Pete said, it's about magnitude minus 4. So it's a really brilliant target. The best thing to do if you're going to observe it visually with your telescope is wait until it's dusk and then try and pick it out with the naked eye and then observe it against a fairly bright sky if you can, because that will really reduce the glare. And if you use a yellow filter on it, that will help as well clean up the disk, and you might see the bright cusp patches covering the poles and some darker markings. They're very subtle, but if you're sensitive to the bluer end of the spectrum, you might well be able to pick those out. You don't need a large telescope for Venus. A 60mm refractor is enough to show you these sorts of details.
It's a tricky planet to observe, actually, isn't it? I know you do a lot of Venus drawings, and I take images of it, but it is quite subtle. You do have to work on pulling out that detail. It's not obvious, and I think for many first-time viewers of Venus, when they look at the planet, it's difficult for them to see anything other than just a completely uniform disk.
Yeah, it looks first time round like a billiard ball with a face on it, but it is a rewarding target though. And to go over to your area of it, imaging, Pete, it's a planet with so many facets. In infrared, it presents different structures and clouds.
Yes.
UV, you can see a lot of structure in the upper atmosphere. So it is a target well worth pursuing.
And of course, when it goes into its crescent phase, then there's the opportunity of trying to image the night side of Venus as well, which is very exciting because I think we're still looking for them. None have been confirmed yet, have they? Looking for active volcanism on the surface?
So telescopically, you're quite right. None has been definitively proved. But there was a paper last year, I forget the author's names now, which is terrible of me, I know, but This team of scientists had been through some old, I think, Magellan data, and they had discovered changes on the surface around what looks like volcanic vents, which could only be explained by volcanism. So we think that there is active volcanism on Venus, and I wouldn't be at all surprised if an amateur astronomer imaging the night side of Venus was the first to pick it up.
Exciting stuff. Okay, well, Mars is also getting exciting as well because that reaches opposition in January. On the 1st of December, it shines at magnitude minus 0.5, and its colour, its sort of salmon pinkishness, if you like, will give it away. It's 2 degrees from the Beehive cluster M44 at the beginning of the month, and it shows an 11 arc-second disk, which is plenty big enough to actually pick out some detail on it, isn't it?
It is. So by now you should be able to see quite a bit of detail. The polar cap in the north and the Syrtis Major is the most prominent marking. But also, you don't need a massive telescope when Mars is above 10 arc seconds to see other details. And the thing to watch out for is white cloud activity, which can occur and make places like the Hellas Basin, which is just south of Syrtis Major, this huge, deep region we think was once a shallow sea, that can fill with clouds and become really brilliant and look like a false polar cap.
Yes, I've seen that actually. Yeah, it's quite amazing. Well, there's an interesting event occurring with Mars on the morning of the 18th of December when the moon will pass across in front of Mars. That happened a couple of years ago, I think 2022 in December, wasn't it? Where we had a lunar occultation of Mars. This one is slightly different because it occurs during daylight hours. You might think, oh, come on, how are you going to see Mars in the day? But it's magnitude minus 0.9, which is perfectly feasible during the day if you use a telescope. You'll probably be able to pick it up with binoculars as well at that brightness. So basically, you've got to find the moon, which is in its if it is gibbous phase, if I remember correctly, and that will be, or the occultation disappearance is about 9:24 UT. With reappearance occurring at 10:15 UT. You can find more details, as ever, in the magazine, but that'll be quite exciting if the skies are clear.
It will. I remember the last one. I got some nice drawings of it as it just went behind Mars and it emerged. So it would be nice to see that again. And we've seen to have a few of these recently. A lot of these celestial events seem to turn up in pairs, don't they? Separated by just a few years.
Yes, they do.
Which is fortunate given the state of the British weather.
Yeah, absolutely. Yes, there's another lunar occultation of Saturn coming up. We had one in August 2024, but there's another one coming up in January, which will be exciting as well. So yeah, you're quite right. You seem to have little clusters of these events, and then they don't happen for ages. Okay, what about Jupiter then? Jupiter's your favourite planet, isn't it?
Well, to be honest, I'm a bit of a planetary tart in that sense, Pete. But my favourite planet really is whichever one I'm looking at. But I do have a fondness for Jupiter because you remember back in the day when telescopes were massively expensive.
Yes.
And you were looking for what you could really do and achieve with a small telescope. And Jupiter was the planet because it's around for a long period of time. It's got a massive apparent diameter, something like 40 arc seconds. And its surface, even under mediocre conditions in a medium telescope, just shows so much detail. So I have a great deal of fondness from it from that point of view. This month, December, it reaches opposition on the 7th of December and will be shining at magnitude minus 2.7 amongst the stars of Taurus. So pretty much visible all night long. So this is quite an opportunity, really.
Absolutely. Well, the fact that it's actually within Taurus is amazing in its own right. I do remember the last time it happened. I'm sure it wasn't 11 or so years ago, but it must have been. But it is quite impressive when it's in that constellation because it's a very distinctive constellation. I mean, you often find planets sort of moving around in the less defined constellations like Pisces and Aries, etc. So it's great to have bright Jupiter, and it is bright at magnitude minus 2.7. That's really going to be a beacon against the stars of Taurus. But of course, being up so long throughout the night gives you the opportunity to do a complete rotation of the planet, something which you can do with a camera, but you can also sketch it, as you do, I think.
Yeah, I'm actually going to go for a full rotation. I've got 2 half rotations.
Right.
Because last time it was like this. I never got a full, long, clear night. So I've got 2 5.5-hour rotation maps that I made, but I will probably go for the full rotation this time if we get the full clear night. To be fair, even if it's patchy cloud with clear intervals about 15-20 minutes, that's still enough to complete
of course yes
a time map of the surface. So and as you say, lots of interesting detail on the disk, and the Great Red Spot, which I believe is continuing to shrink, and we still don't know what the final result of that is going to be.
And of course, you've got the moons as well. The moons always put on a great show. There's some fantastic events coming up with the moons of Jupiter and of Saturn. And again, you'll find lots of details of these occurring in the magazine throughout the rest of 2024 and into 2025. Should also point out the full moon, the moon at full obviously is also at opposition, joins Jupiter on the evening of the 14th of December. It'll be separated by just 4.8 degrees earlier in the evening. On the 31st of December, Jupiter sits 5.8 degrees northeast of Aldebaran, and the Hyades and Pleiades clusters will be nearby. So that's a great time to try and get a photograph of it if you have only a wide field setup. A smartphone will be able to get those clusters and Jupiter in the same field of view. And it's rather iconic. I think it's just a beautiful part of the sky to have Jupiter in. Okay, what about Saturn then? Well, Saturn's ability to be seen at its highest position due south under dark skies is lost from mid-month, about the 10th of December onwards, and then it slowly nudges to the west of south as true darkness falls. It never gets very high in our sky at the moment, but that is improving over time. But there will be an interesting encounter with Venus on the 18th of January next year to look forward to. But it is still an amazing planet to observe. You've observed it a few times?
I have got a few droids. It's still quite low, but it's notably higher than it was. It does now clear the rooftops for about 45 minutes, which is a great improvement on what it was. But it will be nice when it's higher in the sky, because it is a fact that when things are low in the sky, the effect of seeing and even local seeing, heat from the rooftops during winter, it can really affect.
Oh, absolutely.
So, it will be nice to see Saturn higher in the sky. Okay, well, moving further out to the ice giants, Uranus, best time to see it is the 1st of December. Its magnitude plus 5.6, so technically naked eye visibility, but you would need a very dark sky to see that. And it reaches its highest point in the sky as darkness falls, and currently located southwest of the Pleiades, so not really that far from Jupiter, although, of course, it's a much fainter target.
And then finally we have Neptune, which is an evening planet reaching 35 degrees peak altitude under darkness for most of the month. Neptune currently appears at mag plus 7.9 and sits amongst the stars of Pisces, south-southwest of the Circle at asterism, but you'll need binoculars at least to be able to see it.
Okay, well, let's move on. We've got some specials now this month, which are very, very good. As Pete mentioned, some of these involve Jupiter, because there's a number of Jupiter moon events. And on the 1st of December, there are excellent transits of Ganymede and its shadow between 1830 to 1926 UT. And Ganymede is the largest moon of Jupiter. In fact, it's the largest moon in the solar system. It's larger than the planet Mercury.
Yeah.
So because it's quite a long way out from Jupiter, I think I've only got a couple of drawings, a couple of observations of Ganymede in transit with its shadow, because it's actually quite a rare phenomena.
Yes, it is. You need Jupiter near opposition to get them both together on the disk at the same time. And there's another interesting Ganymede and its shadow transit coming up a bit later in the month, which we'll come on to in a second. On the 2nd of Mars, on the 2nd of December, Mars will, I've created a new, that's March, isn't it?
You need to stop drinking before we record these.
That tea's stronger than I thought. Okay, on the 2nd of December, Mars occults the 9th magnitude star, TYC 1398 00878-1. That's got a fantastic name. At 20...
What does the 8 mean? How on earth is that right ascension and declination? I've often wondered where these numbers come from.
Well, the TYC is Tycho catalogue, isn't it? And the -1 at the end, I believe, is an indicator of whether it's in a pair. So -1 is a single star, so most of them will be single stars there.
Okay, well, I think you deserve 5 points if either for actually knowing that or just making something up on the hoof. Either way, you should get some marks for that.
Well, I would think the first 4 digits must be coordinates of some sort. And
I'd have thought so. Yeah,
and then we're talking sequential in the last block of 5. No, I'm sure somebody will correct us in the comments
They'll write
section.
in. They'll write in.
So that occurs at 22.3 UT. So actually, that's going to be quite hard to see. A ninth magnitude star being occulted by bright Mars.
Yeah.
Really hard. So that'll be your challenge for the month.
Okay, on the 3rd of December, appearing close to one another, Io and its shadow transit Jupiter's disk between 2030 and 2246. So we should say something about this, because most of the time when we observe the transits of satellites on Jupiter, the shadows are often quite a long way from the satellite. In fact, it's not uncommon for the satellite to transit then followed by the shadow or the other way round.
Yeah.
But close to opposition, the shadows and the satellite becomes very, very close together, because the sunlight's, shining on them both and creating the shadow very nearby, because it's nearly close to opposition. So this is also another quite a rare thing to do. So getting observations of the satellites with their shadows very, very close by is a very interesting thing to do.
Well, it is really interesting, and also what normally happens if you actually got the timing right and you got a moon transiting Jupiter when Jupiter was at opposition, in theory you would see the shadow in sync with the moon in terms of longitude of Jupiter. But because Jupiter is normally above or below the equivalent of the ecliptic plane, the shadow will be displaced to the north or the south of the moon. But as you head towards an equinox, a Jovian equinox, then Jupiter will appear sideways onto the sun. And because those moons are in an equatorial plane around Jupiter, the shadows will line up with the moons, so they will disappear behind the moons in theory. So we are coming up to a Jovian equinox. I think it's the end of 2026, if I remember correctly. So it will start to get interesting when you see these events. And also, this is a reason why we're also highlighting other events involving the outermost Galilean moon, which is Callisto, because Callisto normally misses Jupiter completely, and its shadow normally misses Jupiter completely. But as you start to head towards a Jovian equinox, they start to interact as well. We haven't quite got that at the moment, but at 0530 UT on the 4th of December, Callisto appears 8 arcseconds from Jupiter's southern limb. And there's a mag plus 11.7 star 2 arcseconds from Callisto, if you have the ability to pick that up. You might pick it up with a big telescope. But Callisto will then move to a position a bit later on that morning where it is just 5 arcseconds from Jupiter's southern limb. So as you can see, it's starting to get quite close to the planet at the moment.
Yeah, it's as you say, it's a fascinating thing to watch. These outer the transits of outer satellites of Jupiter are so rare; they're worth catching if you can. And sticking with satellite transits, on the 6th of December, we have an opportunity to observe Titan's shadow transit Saturn between 1832 and 2230 UT. So hopefully, unless it's really bad weather, there might be a clear spot, and that's well worth trying, because we do not get to observe Titan and Titan's shadow transit Saturn very often.
You might think actually by the time we get to the end of 2025, when I've been reporting on all these events in the Sky Guide in the magazine, you're thinking, oh, when will they end? But actually you get a batch of them around when Saturn is going through its own equinox, and then you'll have a gap of about 13 years or so. In all my time observing the planets, I've never caught a Titan transit or a Titan shadow transit. So I'm really excited about all of these. So I really want to be able to catch one of those.
Yes, me too.
Also on the 6th, we should mention that Mars changes direction from travelling eastward against the stars to westward against the stars as it moves from a prograde direction to a retrograde direction. So this is the first curve in its famous retrograde loop.
And on the 6th also, Europa and its shadow transit really close together between 0310 and 0550 UT.
Yep. And then we get Ganymede and its shadow touching virtually on the 8th of December between 22:30 and 00:54. Io and its shadow will also appear, so it's really close to opposition because Jupiter's at opposition on the 7th, between 03:56 and 06:08.
And on the 9th, Dione's shadow transits Saturn between 1521 and 1835. So this event starts under daylight conditions, and then after that, it moves into dark skies. So worth trying to catch that. You will need a large telescope to see that event.
A slightly easier moon event occurs early evening on the 10th of December when we have the lunar clear obscure effect known as the jeweled handle, and that's very easy to see. That's where the lunar dawn light hits the peaks of the Jura mountain range, a semicircular mountain range around Sinus Iridum. You see it right on the terminator, very obvious when you're looking for that. And also, moving a few days later, on the 13th, as darkness falls, we now have a 96% lit waxing gibbous moon, which is located in front of the southern part of the Pleiades open clusters.
On the 14th, we have the peak of the annual Geminid meteor shower. Sadly, the moon is going to be very bright and in the way, and so this makes the shower quite unfavourable. But it is worth going out and see if you can spot any. You should be able to pick up the brighter ones, but
Yes.
The fainter ones are going to be drowned out by the moonlight, I'm afraid.
On the 16th, it's a moon day again. We've got Ganymede and its shadow transiting Jupiter between 01:42 and 04:55 UT. And then later in the evening, or afternoon into the evening, I should say, we've got Rhea's shadow transiting Saturn between 15:37 and 19:21 UT. It starts in daylight, obviously, and then goes into darkness.
And then on the 18th, as we mentioned earlier when we were talking about Mars, there's the lunar occultation of Mars in the morning. Magnitude minus 0.9 Mars will disappear behind the 89% lit waning gibbous moon between 09:24 and 10:15 UT. Those times will slightly vary depending on your location in the UK.
On the 21st, we have the Northern Hemisphere's winter solstice, which occurs at 09:19 UT. I bet you'll be out watching that, Paul.
Yes.
Representing the instant in time when the sun is at its most southerly declination. So after that, the sun starts to begin creeping up the sky once again as we head towards summer again.
And the days get longer from that point onwards. Actually, it does actually take a considerable amount of time before you notice them. It takes because if I'm not mistaken, the angle between the sun and the ecliptic has to be quite steep. That's why you suddenly notice the nights really pulling out in March, end of March.
Yes,
time.
you do.
So it's a useful thing to know, but it will take a while before that effect is seen. On the 22nd, we have the peak of the Ursid meteor shower. This is best before the 58% lit waxing gibbous moon rises at about 11 o'clock at night. So start before the moon rises.
And then we have another Titan shadow transit, which occurs 17:36 to 21:55 UT on the evening of the 22nd of December. And then there's another shadow transit on Saturn on the 25th of December between 16:34 and 20:17 UT. This time it's Rhea, which is casting the shadow.
And so if you've got a Christmas telescope, put down the Christmas gin and go out and have a look at it. On the 29th at 02:30 in the morning UT, Jupiter's outermost moon, Callisto, sits just 4 arcseconds north of Jupiter's North Pole. And also on the 29th, UK, Dione's shadow transits Saturn's disk, and that's visible from 1917 UT till Saturn sets at about 22 UT.
Fantastic. Well, we have rattled on a bit about moons, etc. So we're just going to quickly go through some of the things which are visible in the star part of the night sky. December and January are the best months of the year for stargazing in the northern hemisphere. For one, the skies get really dark at this time of year with the winter solstice occurring, as we said, about the 21st of December, with the sun at its lowest point in the sky. It means that at midnight it's at its furthest below the northern horizon, so the skies are really, really dark. We've got Orion the Hunter, of course, the mighty hunter, which is fantastic to observe. So much in there. We've got Betelgeuse, which hasn't gone off as a supernova yet.
No, and I don't think it's likely to yet either, but there we go.
Which, you do remember when it dimmed? That was back in 2019, 2020?
I do. It was quite a noticeable dip, but I didn't understand the furor of why people thought that might mean it would go supernova, because supernovas tend to be very bright things. So,
but it was all the calls of, I know it's gone off. We're just going to see the explosion. I'm certain it's gone off and exploding, and its light is heading towards us. And you think, okay, where is it?
Yeah.
But the opposite corner of Orion, we've got the blue supergiant called Rigel, which is the most luminous star in our local part of the Milky Way, which is about 40,000 times as luminous as the Sun. Midway between those two stars, of course, you've got the three stars which form the belt of Orion, Alnilam, Alnitak and Mintaka. Should say them in the right order. Alnitak is the one on the eastern side, Alnilam's in the middle, and Mintaka is on the west. And that's a lovely thing to look at anyway, because if you look at it with binoculars, you'll see lots of stars around there. That's a cluster. That's Colander 70.
It's quite a pretty cluster, actually. It's one of these sorts of things I tend to look at using the finder on the telescope or a good pair of binoculars, because if you use a telescope even on low power, the field of view is too small and you miss it. I think with open clusters like this, you can't go wrong with a good pair of binoculars or the finder.
No. Okay. Just as I'm talking about that, which has got nothing whatsoever to do with Orion or the belt of Orion or anything, it just popped into my head that as we're recording this, which is in October, we have to record ahead of time, of course, to get everything ready for you with the graphics, etc., the star T Corona Borealis still hasn't gone off. No,
you're quite right. So this is one of these variable stars which we were expecting to really brighten up to, naked eye visibility. And it's still dithering. It's still dithering at about, I think, 10th magnitude, something like that. So, you need a telescope to see it. Despite all predictions, it still hasn't gone off. So it just goes to show, doesn't it, that even though you can get predictions ready for stuff for material in the sky observations, they don't always happen.
And now, having said that, of course, it's probably gone off in the time it's taken for us to record this and get everything ready. I know somebody did ask me about it and said, when is it going to go off? And I said, 21st of October. So if it does go off on the 21st of October...
We'll burn you at the stake as a wizard.
Oh, not again. Yeah. Right, so with Orion, it's a fantastic signpost to lots of other things in the night sky, of course. Follow the belt stars up, and to the right you come to Aldebaran, which is in Taurus the Bull, with Jupiter there, of course, also marking Taurus the Bull. Follow the belt stars down and to the left and you arrive at Sirius, the brightest star in the night sky, a rather beautiful star that appears to twinkle, or technically that's known as scintillation, and flash bright colours due to the fact that it's fairly low down. It suffers from atmospheric dispersion, and coupled with the scintillation, that's what causes the colours to flash through.
So I should report on a personal failure here. I tried with no success last year using my 12-inch telescope to try and find Sirius B.
Oh.
Because it's at a wide separation from the primary star.
It's almost at its widest, yeah.
Yeah, but I did struggle to see it. I used transparent clear nights to look for it. It's a bit of a mystery. I was unable to see it.
It's a good one, this. For anybody that doesn't know what we're talking about, this is the Pup star, which is a companion to, it's a white dwarf companion to Sirius A, which is the bright star you can see, which we refer to as Sirius. And the companion is about magnitude 8.5, if I remember correctly. And
yes, and it's not a challenge at all for a telescope with 12 inches aperture.
No, it's not.
But because it's so close to Sirius A, the primary, it gets lost. But I am still surprised not to have been able to pick it up. So I need to try again.
It's a lot harder than you would think. And many people have reported it. Many people have reported they've imaged it as well in the past, and they haven't. What they're doing is they're picking up a star which is close to Sirius, which is in the right brightness range, but Sirius B is really close to Sirius. It's in sort of planetary or apparent planetary size distances from the star. So you need sort of a planetary setup to be able to pick it up next to Sirius. The tricks to get it are to observe it in twilight, because the contrast is reduced from the primary, and also to use an occulting bar, which you can do by fitting a little bit of tape, aluminium foil, for example, over the focal point of your eyepiece and just sticking it there so that it covers half of the field of view, and then just moving it into a position so you block the light from Sirius. So that's another way to do it. If you're using an imaging camera, the safe way to do it, if you've got a planetary imaging set up, is to use an infrared filter on Sirius. There, you've heard it here. That will work every time. Every time I've done it, I've always managed to capture Sirius B.
Okay.
So you use an infrared pass filter on the camera, point the planetary imaging setup at Sirius, and you should be able to see that tiny dot next to it.
I haven't actually tried observing Sirius in twilight, so I think I'll give that a go. That's actually quite a good idea.
Okay.
All right.
Very good. Well, I think we've rabbited on for probably long enough now. So with that, I guess all that remains to say is have a fantastic Christmas and New Year, and we'll be back in January 2025.
Yes, indeed. Thanks, everybody, for listening. I hope you've enjoyed the VP Virtual Planetarium, and we'll see you all next year. Thanks, Pete.
Thanks, Paul.